So in this video, we'll be going through the procedure to go from an unrolled, heat-treated 1018 steel sample down to varying levels of reduction by cold rolling. And this is our cold rolling machine here. It's cold because we're not applying any heat to the sample as we're rolling it. And what this machine will do is, as we feed it through these rolling pins, it's going to squish the material down, decrease its thickness, and impose mechanical deformation on the material. And what you'll be doing over the course of these next few weeks in your lab experiment is figuring out what impact within the microstructure of the material and also eventually the mechanical properties of the material this rolling procedure has on it. And so what we wind up doing is taking the material, so this is heat-treated bar stock that we have of 1018 steel. I've measured the width, the thickness, and the length of this bar initially, because obviously that's what we will use to eventually compare the roll thicknesses of the bar to. And I've marked it with an arrow here, because what we'll find is that if we just kept feeding in and rolling the material in the same orientation time after time, we'd wind up imposing some curvature on it. And we want to try to avoid that. And so we'll track the orientation that we initially fed the bar through the machine with by this arrow, and then we'll wind up flipping it this way as well as lengthwise to make sure that we're rolling it sort of evenly in all of the directions. So the way we use this machine is that we can control the height of this rolling pin by this crank here. And so we initially figure out the height at which our metal bar just barely passes through the rolling machine here. And that will basically be, if we pass it through, then we will be imposing very little deformation in the material. And that's what we'll do to start with. So we'll basically figure out what height the bar is at which it barely passes through. We'll take that down as a note. Here, the dial is set to 25. And so we'll mark that down, and then we'll crank the wheel down in 15, in increments of 15, how it's measured here. That doesn't really correspond to a specific height of the wheel. We'll just use that to qualitatively understand how much we're moving that rolling pin down toward the specimen. So it's initially at 25. We will move it down to 40. And what we'll do initially is, as we deform the material, one thing that will change is the temperature of it. You would find that it would wind up heating up as we deform it. So this is something that we wind up tracking and something that you'll wind up commenting on in your lab report. Why does this happen? Why does, as we roll the material through, we're not imposing any external heat on it, but the temperature of the bar will actually increase as we deform it. And so initially the temperature of this room, 24.4 degrees C. If we measure the temperature of the bar just by touching this thermocouple to it, we'll find, as we'd expect, that the bar is the same temperature as the room itself. So what we'll wind up doing, and I won't talk over the machine as it's running, you can observe me do so, we'll wind up feeding this bar through. We have set this dial to 40, meaning that we're imposing some deformation on it. But so here, I will turn on the machine, and we will feed the bar through, making sure that we don't do so with our fingers. We need to be safe as we operate this. You'll notice that I've rolled up my sleeves. There's nothing loose that would get sucked in to this machine and impose any sort of damage. So we're going to use just this wooden paint stirrer to feed the bar through, and then measure it on the other end.
Close up. So now second pass, 40 to 55. Pass number 3. Okay, so you should see some change in dimension this time. All right, I'm going down to 55 on the index. Temperature going in is 25.2. .7.